Welcome to Brain Vision.
So here on this question, we have to repeat the last problem where we developed the belt speed v, but in the last problem we assume that this height h is 0, but in this case this height is not 0, it is 2 meter, and this length L we have 10 meter, and theta we have 25. Now this is the input data, and then we have to evaluate the speed of the belt, and it will be following the same approach that we did in the last question. That is, there is only one force that would be acting here, that is the mg force, and its component in this direction would be mg sine theta. And again we can apply the variable mass approach here, and we can write that sigma fx is equals to m dot u plus m v dot, and this direction is our x direction. Now in x direction we have only one force, that is mg sine theta. We'll take the component of this mg force in the x direction, so it would be mg sine theta is equals to m dot u plus, now there is no acceleration, so this term would be 0. Here u is the relative velocity of the sand and the belt, which is v here, so we can write this value as v. Now next we can find the mass of the sand over the belt L. So mass would be equals to density times the area times the length. This area is the cross-sectional area of this section, and length is this length, and density is the density of the sand. Now next m dot we have to calculate, that is the mass flow rate of the sand, and it will be equals to the density times the area times the velocity. Now here we have to take the velocity carefully. Now this height is 2 meter, so when the sand is coming, it would be coming like this, and velocity at this point would be under root 2gh. We have just used the conservation of energy to find this expression, so at this point the velocity would be this much. We can put the values under root 2g we have 9.81 times h we have 2 meter. So we can solve this and we'll get vi to be 6.26 meter per second, but we have to take the component of this velocity along this direction, so it would be vi sine theta. So here this velocity would be v minus vi sine theta. This should be taken carefully. So we have all the values, we can plug it here. So m we have rho times area times length, g as it is, sine theta as it is equals to rho times area times v minus vi sine theta. This is m dot, and v as it is. Now here we see that rho and area will cancel out. This rho, area and area. Now we can put the values. So length we have 10 meter times g is 9.81, sine theta is 25 degree is equals to v, we have to calculate vi, we have 6.26 sine 25 degree times v. Now we have only one variable, that is v. We can use our calculator to find this, and we'll get the value of v to be nearly 7.9 meter per second. So this is the required velocity which was asked in the question. I hope you have understood the problem. Thank you.